Good morning everyone, today is the day 2 of the Python training. My name is Sejin Park and I will lead you from day 2 to day 5. So yesterday on day 1 we learned about what Python is and how Python is used in data analysis. And now today, first we are going to learn about essential Python libraries, and second we are going to go through installation and setups. Keep following me and always pause the video if you want to take time to think. So now let's see several essential Python libraries. NumPy is short for numerical Python, and it has long been a cornerstone of numerical computing in Python. It provides the data structures, algorithms, and library glue needed for most scientific applications involving numerical data in Python. NumPy contains a fast and efficient multi-dimensional array object and the array. It has functions for performing element-wise computations with arrays or mathematical operations between arrays. It also contains the tools for reading and writing array-based datasets to disk. And also contains a mature C API to enable Python extensions and native C or C++ code to assist. NumPy's primary uses in data analysis is as a container for data to be passed between algorithms and libraries. For numerical data, NumPy arrays are more efficient for storing and manipulating data than the other built-in Python data structures. Next, let's take a look at Pandas. Pandas provides high-level data structures and functions designed to make working fast, easy, and expressive. Pandas blends the high-performance array computing ideas of NumPy with the flexible data manipulation capabilities of spreadsheets and relational databases such as SQL. It provides sophisticated indexing functionality to make it easy to reshape, slice, and dice, perform aggregations, and select subsets of data. The Pandas name itself is derived from panel data, an econometric term for multidimensional structured data sets, and a play on the phrase Python data analysis itself. Next is Matplotlib. Matplotlib is the most popular Python library for producing plots and other two-dimensional data visualizations. It is designed for creating plots suitable for publication. While there are other visualization libraries available to Python programmers, Matplotlib is the most widely used and as such has generally good integration with the rest of the ecosystem. I think it is a safe choice as a default visualization tool. IPython and Jupyter became one of the most important tools in the modern Python data stack. While it does not provide any computational or data analytical tools by itself, IPython is designed from the ground up to maximize your productivity. It provides easy access to your operating system shell and file system. Since much of data analysis coding involves exploration, trial and error, and iteration, IPython can help you get the job done faster. For me personally, IPython is usually involved with the majority of my Python work, including running, debugging, and testing code. Next is a SciPy. SciPy is a collection of packages addressing a number of different standard problem domains in scientific computing. Let's take a look at the sampling of the packages included. SciPy Integrate is the numerical integration routines and differential equation solvers. SciPy Linear Algebra is linear algebra routines and matrix decompositions extending beyond those provided in NumPy Linear Algebra. Scikit-learn has become the premier general-purpose machine learning toolkit for Python programmers. In just 7 years, it has had over 1,500 contributors from around the world. Along with Pandas, stats models, and IPython, Scikit-learn has been critical for enabling Python to be a productive data science programming language. Now in part 2, let's see the setup of Python. Google Colab is a document that allows you to write, run, and share Python code within your browser. It is a version of the popular Jupyter Notebook within the Google suite of tools. Jupyter Notebooks, and therefore Google Colab, allow you to create a document containing executable code along with text, images, HTML, LaTeX, and etc., which is then stored in your Google Drive and shareable to peers and colleagues for editing, commenting, and viewing. In order to create a new document, access Google Colab through this link. Once here, you can begin a new document or notebook in one of the two ways. Upon visiting the site, a box with your recently visited Colab documents will appear. Select New Notebook to begin a new document. Alternatively, to create a new document from any screen, select File in the top left corner, then select New Notebook from the drop-down box. After you have created a new notebook, you will see an empty code cell. Python code can be entered into these code cells and executed at any time by either clicking the play button to the left of the code cell or by pressing Command-Control-Enter on your keyboard. At the top of your notebook, you will find two buttons, plus code and plus text. Add a new code cell by clicking the plus code button in the top left corner of the document. Add a text cell by clicking the plus text button in the top left corner of the document. When a cell is selected, a toolbar will appear in the top right corner of the cell. This toolbar contains functions specific to the cell. Options include moving the cell up and down, adding comments, and deleting the cell. As with other Google apps, Colab notebooks can be shared. Look for the Share button in the top right-hand corner of the window. Google Colab documents can also be shared in Google Drive, just like the other types of documents. If there are any problems while following me through, welcome any questions on the email highlighted above. Thank you for listening and have a nice day.